Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 motion in a plane. Today we are going to study about introduction to types of motion. See here, we completed the vector part of this chapter. Right? Now we have to move the next part of this topic is projectile motion. But before going to study about projectile motion, first we have to study some basic terms related to types of motion. So now today we are going to study introduction to types of motion. Yes, so motion in a plane. In this chapter, let us study the introduction part of motion in a plane because till now we concentrated only on vectors. Now we are going to move the next part of this chapter, which is very important, and that is projectile motion. To understand projectile motion, once we have to study the introduction part of motion in a plane. Yes, observe here, this is motion in a plane. As I explained in the first class, motion in a plane has two-dimensional x-axis and y-axis, xy plane, yz or zx plane we can consider. You can observe in this picture the aeroplane is moving in the space. So how it is moving? It is moving in the two-dimensional, right? So this is motion in a plane. How rest and motion are relative terms. Yes, we studied kinetics in the branch of mechanics. First we have to know what is mechanics. Mechanics is the branch of physics which deals with the study of motion of objects. The study of motion of object that comes under the branch of physics, that is mechanics. In mechanics, again there are two branches and they are kinetics and kinematics. Kinetics and kinematics, but here kinematics is not going to consider any reference to the cause of motion. Without any reference, we are going to study simply the motion of object, so we can call it as kinematics. Yes, what is kinematics? The branch of mechanics that deals with the study of motion of objects without any reference to the cause of motion is called kinematics. Yes, then we have to know what is a frame of reference. Frame of reference is very important to understand reference to the cause of motion. In general, frame of reference means if any vehicle is moving with respect to a person sitting on the roadside, or you can take a bridge, if the train is moving, how you came to know the train is moving? Because it is changing its position with respect to that bridge or the river or the road. So we have to consider frame of reference. How to define frame of reference? Observe here, a system of coordinate axes with regard to which an event is described. We are going to describe an event. We are going to describe the motion of the object with respect to coordinate axis. We can call it as frame of reference, right? Then rest and motion are the relative terms. Observe here the train. Here what is rest? We can directly say that the train is at rest. What is rest here? Because the train is not changing its position. The train is at rest. Then what is motion? Here you can observe the train is moving. Then how to define motion of the object? You can observe the train is moving with reference to the bridge. With reference to the bridge, the train is moving, right? So we can say that motion means change of position of an object with respect to time and point of reference. What is motion of the object here? Motion of the object is change in the position of an object with respect to time and point of reference. This is called motion. Now the question arises, how many types of motions are there? So we already studied motion of a particle can be divided into three types. In three ways we will get motion of a particle, and they are motion in one dimension, motion in two dimension, and motion in three dimensions. One dimension, two dimensions, and three dimensions. These are the three ways for the motion of a particle. Observe the MCQs here. The first question. Motion is a change of dash of an object with respect to time and point of reference. Options: position, movement, place, object. Which is a suitable answer here? Position. Motion is a change of position of an object with respect to time and point of reference. Then second question, how many types of motions are there? Option 2, 1, 3 and 4. How many types of motions are there? There are three types of motion, and they are motion in one dimension, two dimension and three dimension. Then types of motion. Yes, there are three types of motion. First we can study motion in one dimension. Observe this picture here. The ant is moving in a straight line. How the ants are moving here? The ants are moving in a straight line. This is a straight line motion. Or we can take it is rectilinear motion or linear motion. It has straight line motion or linear motion, or we can also call it as rectilinear motion. Rectilinear motion means the object is moving along a straight line. Observe, the car is moving along a straight line. Now we can say that this motion is in one dimension. Only one axis we have to consider. So this is called rectilinear motion or linear motion. Then second type is motion in two dimensions. Observe this picture here. Motion in two dimensions. Yes. So there is a house here. This is a bird. How it is moving? Observe. Whether it is moving in a straight line? No. Observe this picture one more time. Yes, observe here, the dolphin is jumping in the sea. What type of motion it is? Observe the two pictures. The dolphin is jumping here. In the first picture, this bird is moving, and in the second picture, the dolphin is jumping in the sea. What type of motion it is? This is having two dimensions, two-dimensional motion. Observe one more example. Cockroach moving on a floor. Yes, observe here. The cockroach is moving on a floor. How it is moving? Whether it is moving in a straight line? No. Observe one more time. The cockroach motion on the floor. So this cockroach is not having straight line motion. So this cockroach is having two-dimensional motion. So two-dimensional motion is called motion in a plane. This is motion in a plane. When object or the particle is having two-dimensional motion, we can also call it as motion in a plane. Now, motion in three dimension. The third type of motion, that is motion in three dimension. Yes, the motion in three dimension means the motion in space. Observe this picture here. The honeybee is moving in the space here. So this honeybee is having three-dimensional motion, or we can also call it as the motion in space. Right? Now observe some MCQs based on this motion. Motion in one dimension is a dash motion. The options: curved motion, circular motion, straight line motion, rotatory motion. Observe the question. Motion in one dimension is dash motion. One dimensional motion means straight line motion. When the particle is moving in a straight line, we can call it as one dimensional motion. Then second question, motion in two dimensions is also called options: motion in a space, motion in a plane, motion in a straight line, linear motion. Which is the right answer? Motion in two dimension is also called as motion in plane. Right? Then, examples for motion you can observe. Imagine a cannon is launched at an angle from the top of very high cliff. Imagine that the cannonball does not encounter a significant amount of air resistance. Observe this picture here. This is a cannon. A cannonball is launched at an angle from the very high cliff. At this position we considered a cannonball and it is at the top of the high cliff. Now here for this cannonball there is no air resistance, means the air is not opposing this cannonball. The resistance from the air is completely negligible. Now observe this picture here. What could be the path of cannonball and how could the motion of cannonball be described? The question is, what is the path of this cannonball and how could the motion of cannonball be described? Whether it is one dimensional or two dimensional, how to describe its motion and what is its path? Yes, observe here. In the absence of gravity, if there is no gravitational force, then the cannonball follows a straight line. That cannonball moving in a straight line when there is no gravitational force, right? Then the gravity accelerates that object downward, but it is unable to affect the cannonball. In the absence of gravity, the cannonball follows a straight line path. And this is consistent with Newton's law of inertia. You studied in your high school days about Newton's laws of motion, law of inertia. Newton's first law is also called as law of inertia. If there is no gravitational force, in the absence of gravitational force, this cannonball is moving in a straight line. The cannonball, it follows a parabolic path. As the ball rises towards its peak, it undergoes a downward acceleration. Suppose if the gravitation is present, because of gravity, this cannonball follows the parabolic path because this gravitational force that exerts that ball in the downward direction. As the ball falls, it still undergoes the downward acceleration. It is all because of gravitational force. This downward acceleration is depicted by a change in vertical component of velocity. Observe this picture. The cannonball is moving along a straight line if it is a gravity-free path, means in the absence of gravity. If the gravitational force is present, because of this gravity, this cannonball follows parabolic path. It will come in the vertically downward direction. So this is one example for motion in a plane. So this parabolic path we are going to call it as projectile motion. So about projectile motion we can study in detail in the next session.